A perfilagem de poço é uma metodologia que utiliza sondas para obter dados de propriedades físicas das paredes do poço que atravessa o meio geológico. As sondas, também chamadas perfiladores, adquirem dados de propriedades elétrica, elástica, radioativa, térmica e etc. Os dados podem ser transmitidos com ou sem cabo e são registrados em superfície. Depois de processados, são interpretados e fornecem informações do meio geológico. São mostradas nesta videoaula imagens da aquisição de dados de uma ferramenta de imageamento. As etapas de aquisição, utilizando fontes radioativas, também são mostradas em detalhe. Essas imagens, com as fontes radioativas, foram adquiridas com todas as normas de segurança durante um treinamento com o técnico que explica todos os procedimentos. Tais imagens podem facilitar o entendimento do trabalho, uma vez que as normas de segurança não permitem que pessoas não capacitadas a manipular fontes radioativas participem desse tipo de aquisição. As imagens foram adquiridas no poço FRJ1RJ, que fica localizado no campus da UFRJ, na Ilha do Fundão. Os detalhes das ferramentas e aquisição de dados podem ser encontrados nas referências listadas no final do vídeo e estão disponíveis para consulta.
So procedure for putting on the density source. First of all, remove the thread protector from the tool. Okay, that protects the threads. Make sure the threads are clean. Onto the source. And this simply threads onto the tool. You thread that by turning until that's tight. Okay, so that's now good and tight. And now we need to connect this to the tool, but we don't remove it from the source container. We just pull over to one side so that that remains in its safety container. Remove the sonde cap. Connect to the cable head, reserving the keyway, tighten that up, that's good and tight. Okay, move that a little bit closer to the borehole. So now I'm going to lift the tool out of its safety container straight into the borehole. So the radioactive source will be exposed, but only for a very short time. Okay. Straight in. Now it's underground, it's already relatively safe. Cable over the tripod wheel, and then keep your fingers out of the way of the wheel. So everything is safe, no fingers trapped in there. And that's how you put cesium source onto the density tool. Good. Good. So now the logging is completed, I've left myself enough cable so that I can safely bring the tool up and leave me plenty of room to maneuver the tool. So I have plenty of cable in the borehole here. So I remove the tool, I'm going to move it straight into the source container so it's safe straight away. There you go, put it straight into the container, and rotate it until it locates in its keyway. Okay, so you can feel it locked. So that can't turn until I start to unscrew the source. But I don't do that because I'm still connected to the cable. So I bring it to one side, just blow away any moisture, disconnect. and now I simply unscrew the radioactive source again. That's unscrewed, and that can now be safely locked away and taken back to the radioactive source store. Put back on your thread protectors on both ends. And that's now complete. Good. So, it's a very similar procedure for the neutron tool. This time we have a neutron source and the single neutron tool. We need to open it. We'll remove the thread protector from the tool again. We just check that it's a neutron tool by confirming that we have a nylon piece in the centre here, so we know it is the neutron tool. Put that onto the source and attach in a very similar way to the density tool. So that's now tight. And again, we don't remove the tool from the container. We simply tilt it over so that we can make the connection to the cable head. Remove our thread protector again. Make sure that's tight. Okay, so again, I'm ready now to just quickly take it from the container, put it straight into the borehole so that the exposure is a very, very short time period. Okay, lower into the borehole, onto the tripod wheel, and then move your fingers away. Your fingers don't get trapped. And that's the tool deployed in the borehole. Okay, having completed our logging, we now need to put the source back into its container, so the reverse applies. We simply take the tool out of the borehole, get ready to put it straight into its container. We need to rotate it so it locks into its keyway, just like that. And now we need to remove the cable head. Let's blow away any moisture. Remove the cable head. Replace the thread protector again. And now unscrew the source. Place our thread protector on the tool once more. And we can lock the source container. For WinLogger data. The WinLogger file is a calibration disk.
Okay. For all OPTV.
At the moment I'm just setting up the communication levels which are a factor combined with the impedance of the logging cable. So I'm just setting up the gain and drive settings that we need to communicate with this tool, which is down in the borehole at the moment. So we've got a downhole drive, an uphole gain, and an uphole signal drive as well, plus our communication speed in board. So that's actually looking like it's acquiring data okay. What I need is a specific calibration file for this tool so that we can have the image oriented correctly in terms of northeast, southwest, north. What this tool does is it images the borehole wall and then it unfolds the borehole into a planar view and orients that image from north, east, south, west to north. And the idea of this is that if we have any planar features dipping through a borehole, like a fracture, or bedding planes or any metamorphic structures, when we unfold that into a plane, that dipping structure becomes sinusoidal. Okay, and we can measure the dip angle from the amplitude of that sinusoid. That measures the amount of dip, and we can calculate the dip azimuth by the phase of the sinusoid. So that way we get our dip angle and dip azimuth, and we can build up a structural picture of the borehole that way. This looks to be communicating okay. Calibration is, I'm just setting up the depth at the moment, so we need to just bring that up a little bit so that we can use our depth reference, which at the moment is top of casing. So at the moment the top of our tool is now level with the top of casing of the borehole. My lighting or my exposure. So this is the image north, east, south, west, north. So at the moment we can see it's skewed. That's the steel casing. Yeah. Okay. The tool is still brilliant. Typical lithological bounds that you get in these nices, and I guess that if we actually compare this to the natural gamma log, we will see that some of these areas are high natural gamma areas where we've got more yeah. Well, we're going to take it out, so yeah.
Open and to fix it.